today's class from Unit 1 Metallurgy, we are going to discuss continuation of refining process and application of metals. In the last class under refining process, we saw distillation, liquefaction, electrolytic refining and zone refining. Now we are going to see vapor phase method. In this method, the impure metal is treated with a suitable reagent and converted to a volatile compound. Then the volatile compound is heated, means it will decompose to give pure metal. So how are metals refined by vapor phase method? In this method, the metal is treated with a suitable reagent which can form a volatile compound with the metal. Then the volatile compound is decomposed to give the pure metal. Understand, children? Yes. Metals like nickel, titanium and zirconium are refined by vapor phase method. Now we are going to see how nickel is refined by Mond process. Yes, the method or the process used for refining nickel is Mond process. Understand, children? Yes, the reagent used in this method is carbon monoxide. Here, the nickel is heated with carbon monoxide. Okay, ma? Yes. Now we can see the process. In this method, the impure nickel metal is heated with carbon monoxide around 350 Kelvin. Okay, the impure nickel is heated with carbon monoxide CO around 350. Okay, 350 Kelvin means a volatile nickel tetracarbonyl. Okay, NiCO 4 times. Nickel tetracarbonyl. Okay, a volatile nickel tetracarbonyl will be formed. Okay, children. Yes, then the solid impurities are left behind. The impurities will not react with carbon monoxide. Okay, ma'am. The formula of carbon monoxide is CO. Okay, yes. So the equation for the formation of nickel tetracarbonyl is Ni plus CO gives NiCO 4 times. On the product side, okay, yes, in the complex NiCO 4 times. Okay, nickel tetracarbonyl, it is a complex. Understand, ma'am? Yes, in the nickel tetracarbonyl complex, there are 4 CO. So before CO on the reactant side, we should write 4. Okay, ma? Yes. So the balanced equation is Ni plus 4 CO gives NiCO 4 times. Okay, ma? Yes. Here the carbon monoxide and the nickel tetracarbonyl complex are in the gaseous state. So write G. Then the nickel metal, it is in the solid form. So write yes. Okay, children. Then and the next step, the nickel tetracarbonyl, okay, is heated around, nickel tetracarbonyl is heated around 460 Kelvin, means it will undergo decomposition and decompose to give a pure nickel. Understand? Yes. So in Mond process, the nickel metal is refined by thermal decomposition method. Okay. Yes. So the equation for the decomposition of nickel tetracarbonyl is NiCO 4 times gives Ni plus 4 CO. Understand, children? Yes, here we will get a pure nickel. Yes, an easy method only. At the same time, an important 2 mark or 3 mark question. Okay, ma? Yes, then next we are going to see purification of zirconium and titanium by Van Arkel method. Yes, zirconium and titanium are refined by Van Arkel method. Okay, it is also one of the thermal decomposition method only. Now we can see how, okay, titanium is refined by Van Arkel method. Okay, yes, the impure titanium metal is heated in an evacuated vessel with iodine at a temperature of 550 Kelvin, means yes, a volatile titanium tetraiodide vapor will be obtained. Okay, yes, understand, ma? titanium, the impure. Okay, the impure titanium is heated with iodine. Here iodine is the reagent. Okay, yes, what's the temperature? Here the temperature is 550 Kelvin. Okay, when the impure titanium is heated with iodine, yes, the solid iodine at a temperature of 550 Kelvin means a volatile titanium tetraiodide. The formula of titanium tetraiodide is TiI4. Okay, so a volatile titanium tetraiodide vapor will be obtained. Okay, the impurities will not react with the iodine. Understand, ma? Yes. The impurities will be in the vessel itself. Okay, yes. And in the next step, the titanium tetraiodide vapor, okay, is passed over tungsten filament at a temperature of around 1800 Kelvin. Okay, yes, the titanium tetraiodide vapor is passed over tungsten filament and heated to a temperature of around 1800 Kelvin means the titanium tetraiodide vapor will undergo decomposition and will decompose to give pure titanium metal. Okay, the pure titanium will be deposited on the tungsten filament. Okay, children. Yes, here the iodine will be obtained in the solid form. We can use it again. Understand? Yes. So the equation is TiI4. Yes, titanium tetraiodide vapor. Yes. What's the decomposition temperature here? 1800 Kelvin. Okay, yes. So, TiI4 decomposed to give pure titanium Ti plus I2. So, the balanced equation is TiI4 gives Ti plus 2I2. Here, the iodine and the titanium metal will be in the solid state. So, write yes. Then, the compound TiI4 will be in the vapor state. Okay, ma? Yes. One of the important 3-mark question. Okay, yes, explain the refining of titanium by Van Arkel method. Under the same temperature condition, zirconium, okay, can also be refined. Okay, yes, that's all about refining process. Then next we are going to see application of metals. First we are going to see application of aluminium. Aluminium is the most abundant metal. We know it is the third most abundant element in the earth crust. It is a good conductor of heat and electricity. Then it also resists corrosion. Yes, now you can see some of its application. Many heat exchangers and sinks and day-to-day cooking vessels are made of aluminium. Yes, many heat exchangers and sinks and our day-to-day cooking vessels are made of aluminium. Then it is used as wraps. That is, aluminium foils is used in packing materials for food items. Then we know aluminium is not a strong metal, but its alloy with copper, manganese, magnesium and silicon are lightweight and strong and are used in design of aeroplanes and other forms of transport. Then, as aluminium shows high resistance to corrosion, it is used in the design of chemical reactors, medical equipments, refrigeration units and gas pipelines. Yes, as aluminium shows high resistance to corrosion, it is used in the design of chemical reactors, medical equipments, refrigeration units and gas pipelines. Then another use, it is a good electrical conductor and also a cheap metal, and hence it is used in electrical overhead electric cables with steel core for strength. Yes, aluminum is a good electrical conductor and a cheap metal, and hence it is used in electrical overhead electric cables with steel core for strength. Yes, that's all about the application of aluminium. Then next we are going to see application of zinc. We know zinc is used for galvanizing iron and steel. Okay, steel materials to protect them from corrosion and rusting. Okay, ma? Yes, the coating of iron or steel with zinc is called as galvanization. Okay, yes. So metallic zinc is used in galvanizing metals such as iron and steel structures to protect them from rusting and corrosion. That is first use. Then another use, it is also used to produce die castings in the automobile, electrical and hardware industries. Yes, zinc is also used to produce die castings in the automobile, electrical and hardware industries. Then zinc is used in the manufacture of many products such as paints, rubber, cosmetics, pharmaceuticals, plastics, inks, textiles and electrical equipment. Okay, yes. Then zinc sulfide is used, okay, in making luminous paints, fluorescent lights and x-ray screens. Yes, zinc sulfide is a 10. Yes, okay, is used in making luminous paints, fluorescent lights and x-ray screens. Then another use, it's alloy called brass. Brass is an alloy of zinc and copper. Okay, used in water valves and communication equipment. Yes, I mean the brass alloy is used in water valves and communication equipments as it is highly resistant to corrosion. Okay, children. Yes, that's all about the application of zinc. You study minimum 3 application. Okay, for aluminum and zinc, at least minimum 3 applications. Then study all the uses for 1 mark. Then next we are going to see application of iron. Iron is one of the most useful metals and its alloys are used everywhere including bridges, electricity pylons, bicycle chains, cutting tools and rifle barrels. The next use, cast iron is used to make pipes, valves and pump stoves, etc. Magnets can be made of iron and its alloys and compounds. Then an important alloy of iron is stainless steel and it is very resistant to corrosion. It is used in architecture, bearings, cutlery, surgical instruments and jewelry. Then nickel steel is used for making cables, automobiles and aeroplane parts. Then chrome steels are used for manufacturing cutting tools and crushing machines. Children, that's all about the application of iron. Study for 1 mark and 3 mark. Then next we are going to see application of copper. The first metal used by human being is copper. So copper is the first metal used by the humans. And extended use of its alloy, bronze. Bronze is an alloy of copper and tin, resulted in a new era called Bronze Age. Then copper is used for making coins and ornaments along with gold and other metals. Then copper and its alloys are used for making wires, water pipes and other electrical parts. Yes, that's all about application of copper. Then next we are going to see application of gold. Gold, one of the expensive and precious metals. It is used for coinage and has been used as standard for monetary systems in some countries. It is extensively used in jewelry in its alloy form with copper. It is also used in electroplating to cover other metals with a thin layer of gold, which are used in watches, artificial limb joints, cheap jewelry, dental fillings and electrical connectors. Then gold nanoparticles are also used for increasing the efficiency of solar cells and also used as a catalyst. Children, that's all about the application of metals. Study all the applications for 1 mark. Then I already told you, you should study minimum 3 application of each metal. Children, that's all about the Unit 1 Metallurgy.